So, as I hope you're becoming used to, as is the pace of the World Summit, we are shifting gears again. We focus now on a range of different topics like the limits of the quality of generative AI, infrastructural concerns, the application for social enterprise, which again, I'm feeling very old not knowing anything about, but that's why we come to these events, to learn. We turn our attention now to a really, perhaps all applications of AI are in their own way important, but a really significant use of AI in the field of healthcare. It's often the case that when friends of mine over a few beers say, AI is going to take over the world. There's no goodness in it. The robots are coming. It's Terminator 2 all over again. I often cite the use case of the use of AI in detecting cancer in patients. And that application having such an unambiguously clear and effective impact, a positive impact on the world. So I am delighted to be able to bring to the stage an expert in that area and many more. So the title of our next talk is Transforming Cancer Registries with Machine Learning and Neural Networks. Professor Adhari Alzaabi, please join me on the stage. The professor is based in Sultan Qaboos University College of Medicine and Health Sciences. She is a cancer prevention and AI expert. She's on a mission to revolutionize patient care through innovative AI and prepare future doctors for this brave new era that we're now in with the use of AI and the intersection of medicine. So an absolute pleasure to welcome you to the stage. Enjoy your talk. I know I will.
Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone into this session. Well, I enjoy the cocktail of topics in this session. So from enterprise to e-commerce and now healthcare. So I usually start my talk with a question, asking the audience, how many of you know someone, a relative or a family member have been diagnosed with cancer? Raise your hands. So I can see most of you. Few years ago, when I used to ask this question, there were very few people who know someone who is diagnosed with cancer, and this reflects actually how fast this disease is growing and it's increasing in incidence. So I'm talking today about cancer registry. Actually, AI is impacting healthcare in a lot of aspects. And in cancer specifically, it helps in early diagnosis, in precise diagnosis, and prediction. But specifically in my talk, I'll be mainly talking about cancer registry and its abstraction. So please consider this as work in progress. I'm not showing any app, but I'm showing the progress of our project so far. So if you look at this map, you can see that cancer is considered the leading cause of death among most of the countries in the world. It is the second leading cause of death in other countries, but in high economic countries, high income countries, it is the leading cause of death. And therefore, countries are trying their best in order to know the cause, risk factors, and to allocate resources in order to tackle it. If we zoom in into our region, the GCC and Oman specifically, there is no exception. Actually, there is an increase in cancer at an alarming pace, where majority of cases nowadays diagnosed are young. By young, we mean less than 50 years of old, which is a productive year. So we are losing a lot of lives for a disease that needs a lot of attention. Majority of countries, they are doing something called cancer surveillance. And in cancer surveillance, they are trying to collect as much as they can data about the patient, from diagnosis till whatever the end result. Is it death? Is it cure? Is it relapse? And whatever. So from this, the surveillance helps countries and institutes to allocate resources. One of the surveillance ways is to do and to report and to collect data into cancer registry. Is there a pointer here? So for cancer registry, every country has its own cancer registry where the data about the patient and the trend of disease is registered. That helps countries and institutes to track trends over time, the incidence, mortality, and whatever. It helps to allocate resources and plan any prevention campaign and screening programs. It also helps to evaluate the effectiveness of whatever intervention they have introduced. And this is how cancer registry works. For example, if I was diagnosed with cancer, I will be detected in a hospital, and there is an assigned personnel who will be sending a notification to the whoever cancer registry place, and then these people will come to abstract data from my electronic health record. Then this data will be coded according to standardized international guidelines. Then it will be linked to IARC, which is the International Agency of Research on Cancer. And then again, these people will come again to my data in order to collect what happens to me after the diagnosis and how I'm responding to treatment. And then the report will be published. Unfortunately, this whole process till today is done manually. There are people who will be notifying the assigned person. That person will come, look at the data, collect the data manually, put it online, and that online thing will be transferred into a report. This is very tedious. It is very expensive. There are lots of errors and missing data, and it is unsustainable. Also, having it being manual make the report delayed. There is, for example, if a case diagnosed today, it will not be recorded in the report till 24 months later because of this process and tedious process. Therefore, people are thinking, can AI help? Especially that these data are collected from health records, and health records are text. And now you know LLM is easy to deal with text, and AI is very happy dealing with text. So with AI, we plan to dig into these texts and try to automatically extract this data and make them available whenever the patient is diagnosed. And this is similar to this project by the US and the NIH, which is modeling outcomes using surveillance data and scalable AI for cancer, Mosaic, which aims actually to develop a scalable NLP in order to detect such data and to report the cancer, and any reportable cancer very automatically. So if you look at the data where cancer registry information comes from, it is very unstructured data. It is data that was written by human. So the doctor will be writing the report or whatever information about the patient, and now we need the AI tool to go and dig for information in this data. So what basically the idea is to look at the report, then highlight the information that are needed for the cancer registry, and then this data will be extracted, converting the unstructured to a structured. Sounds easy, yes, but it's not actually, for different reasons. Look at this. For example, if the patient has cancer and I teach the machine to detect the word cancer, that will be as straightforward. So it will detect cancer as is. But let's say that the second blue box, it says history is inconsistent with stroke. And if I tell the machine to detect the word cancer, it might detect this case as cancer case, which in fact it's not. It's inconsistent with cancer. The same with the patient has these symptoms, we are trying to exclude cancer. Or the patient has mother who has cancer. So that means the word teaching the machine to detect cancer as a word will give us a lot of errors. Therefore, we need to contextualize the content. And when we teach the machine, it's not only word by word, but also the context. And this is the hard part of it. The second issue or struggle that we had is the temporality of symptoms, of data. Cancer registry is not one-time job, so it's not something that will be collected at one time. Instead, the patient has to be followed up in order to see how he's responding to treatment. So the temporality of information makes it even harder. Therefore, what we did actually, we collected data about patients diagnosed with cancer in the past 5 years in Oman, and they are diagnosed from different institutes. So all data from different institutes were extracted into one single hub, and that this information were transformed and de-identified where all personal identification information were faked, and then they were loaded into a system, and that system is the NLP, which I will be talking about in a minute. So this was the time flow of our analysis. So the clinical records look like that. There's a record of a patient. It was going through the de-identification process. Then the data were extracted, and then it was contextualized. We considered the context of the information, and then they were cleaned up by using UMLS, which is Unified Medical Language System, in order to make it more standardized. Here how it looks like. So we have an expert pathologist, an expert physician and oncologist who went through the data and highlighted every single word. And then they labeled every word. For example, abdomen and pelvis is an organ. Right and left is a laterality. For example, this is histology, this is grade, this is stage. So they were pointing at every single word that is needed for the cancer registry, and they label it as it means this and that. And then after this, actually all this annotation happened by following standardized guidelines, which is updated very frequently. And mainly we considered 5 types of cancer: breast, colorectal, thyroid, prostate, and lungs. So we applied these NLP programs into these data, and our objectives, we had 2 objectives. Objective number 1 is to consolidate the TNM. By TNM, I means this is a staging system. So it means tumor, lymph node, and metastasis. For any patient who's diagnosed with cancer, we need to specify the extent of the tumor, the lymph nodes that are involved, and is it inside the organ or is it getting outside the organ? So for the TNM staging is one of the hardest tasks to be done, but we tried it using natural language processing. And here, for staging, for example, if the term was used, tumor invades into, but not through the visceral pleura, the system should give it stage 2, according to the guidelines. If it says 8 lymph nodes negative for tumor, it will label it as stage N0, which is really a hard thing because there are a lot of overlaps. So this is our data. We divided our data into training, validation, testing, and we use this protocol for lung, colon, and prostate. And these were the results. Actually, we used regex, which is a rational extraction NLP program, CRF, and then we use a combination. For the strict matching, it was actually, look at the F1 score. It was really giving us a good prediction of the TNM stage for partial and for the partial and for the strict. Even for the partial, it was way better. If you look at different types of cancer, we can see colon cancer got the highest accuracy and highest accuracy in prediction. There are different reasons for that compared, for example, to the lung. Lung got the least prediction accuracy to detect the TNM. Why is that? Because, for example, now this is a conclusion. For the M stage, which is detecting absence or presence of metastasis, the prediction was really high. It reached up to 98% in all types of cancer. And if you go to the TN specifically, colon cancer got the highest, and there is a very simple reason for that. Its colon staging criteria is way easier than the lung one. So if you look at the criteria of TNM staging for colon cancer, it's way easier, not a lot of overlap. This is why it gets a higher prediction value. For lung cases, actually majority of cases, they lack the staging system or the staging wording. Therefore, it was getting the lowest accuracy. We published this work a few years ago. The second objective is if we can use the same model in order to fill the form of cancer registry automatically from pathology reports. And if you look at the cancer registry form, this is used by majority of institutes and countries. So there is a lot of data to be collected about the patient and his cancer, clinical and pathological. So we try to use NLP in order to fill these forms automatically once the system has access to electronic health records. And actually, we use regex and DeepFi. The difference between them, regex was not trained to any clinical data. It's very generic one. But DeepFi was particularly trained on cancer data. So you will be surprised with the results when we try them both. We try to extract this information, cancer primary site, histology of the cancer, grade, pathological TNM stage, and summary stage. After de-identification of patient's information, this is what we found. We found that regex outperformed DeepFi in all aspects. But if we compare the two, regex did great in detecting primary site, histological type of cancer, and laterality, but it did very bad in the rest. DeepFi did bad in all of them, although DeepFi was cancer-specific or trained on cancer data. We assume it will be the opposite, but there are reasons for this. This is the reason. DeepV was trained on data, not our own data. It was trained from data from Sears in the US. And they have different format of writing their pathological report. Therefore, it didn't do well in our own data. But regex, it was trained on our data. Therefore, the prediction was way better. The other issue with DeepV and regex when they are detecting TNM was this. We use in medical, in pathological report to say T0, T1, T whatever in reflection to the tumor. But we found out that the reports have similar T0 and N1, but it's not for not for the disease itself. It is for labeling the patient, for example, or labeling the specimen. It wasn't related to the tumor itself. Therefore, the system was reading them as TNM. That makes a lot of issue for the prediction. This was published and presented in different conferences, and this is a major issue actually we have. We try to clean the data, but still these noises are still there. So the limitation of the work that we have been doing is the unavailability of training data. Now we are trying to connect and get so many data from different institutes because the more data you have from different institutes, the better the algorithm in its prediction it will get. Also, one of the problems and challenges is frequent changes in coding standards. These books that I showed you that so the ICD and the guidelines for staging and whatever of cancer, they are keeping it changing every 5 years. So whenever we build a system now, it might not work after 5 years, and it has to be updated. Clinical guidelines, there are lots of overlap, especially for lung cancer and prostate cancer. So our plan is to use the ensemble learning. For this, we are planning for every single task. For TNM, there will be a task, a tool. For every single task, there will be a tool, and then this tool will be collected into one big head that will combine them and predict and do the prediction model by itself. And now we are trying LLM. You know, LLM is very smart and using in dealing with text. So we're trying to find out if LLM can surpass NLP and other tools in digging and the unstructured data of cancer reports. This is the team we have from Computer Science Department and the NCD Department in Ministry of Health. This is if you need any discussion and question and answer for this project. And thank you.
Thank you so much, Professor. Really interesting presentation. I don't know about you, but I find it a lot of the times in presentations when you come to AI conferences or conferences about new big technology ideas, it's often the big ideas that get shown on stage. It's the big vision, the future, the aspiration, the theory. It was so interesting to see the very, very fine practical detail of the challenges with cleaning and accurately modeling the data. Was that something that you expected going into the project, or did you think, right, once we have the data clean, then we'll move on to the next step and that'll be easy? Or did you find yourself kind of in a sand pit going, okay, gosh, this is really going to take more time than we thought?
Yeah, actually, when you deal with healthcare data, it's very specific. It's very special data, lots of privacy and lots of confidentiality. And things become even more difficult if you are dealing with unstructured healthcare data, which means data that is written by human. We cannot guarantee humans are writing the same style and the same order and the same whatever. So we expected that, but after the cleaning, we thought now life is becoming easier, but actually it's not. So whenever we collect more data and collecting information from different hospitals, things become worse and worse. Yeah, but we're trying our best.
Oh God, that's a really, really interesting perspective. I'll let you formulate your first questions, and I'll come to the audience for questions now. So if you could think about what you'd like to ask most. Healthcare is one of those areas where I really feel when my children are old enough to understand the way that we approach healthcare, we will seem like dinosaurs to them. I'm looking so forward to the stage when my children ask me to describe my experience of healthcare and how healthcare was approached when, I was young. I'm so looking forward to the day that they look at me with shock and horror because we've come so far. Thanks to the work of people like you. I'm always curious to find out, and this is a little curveball question, what was something that you expected to happen and it didn't work out, or something that was surprised you on the journey to create these models and to try and do this excellent work?
Well, I thought it will be hard to get the data at the beginning from the Ministry of Health, but it seems people are starting to believe in the power of AI.
Brilliant.
So we didn't have a problem. Actually, they provide us with the data, and they were happy to even make it publicly available because there is a lack of training data. So having this data available for people to train their own systems, that's something I didn't expect actually from Ministry of Health, and it happened.
What an amazing surprise, and really also a testament to the forward-thinking nature of the ministry, and perhaps also to the wider global acceptance of the potential power and results from the application of AI to healthcare data. One can imagine years ago the answer very quickly and very simply would have been no. But people are realizing the risk is worth the reward to share this data not only with your own internal resources, but to make it more publicly available. Really innovative and forward-thinking. I'm really encouraged to hear that it was a good surprise you shared.
Yeah, it was. It was really a big surprise for us.
So I'm sure there are people in the audience who would rather ask their own questions than hear me. So I'll take the first question if you want to put your hand up.
Let me ask them a question.
Excellent idea.
Yeah, so now as healthcare professional, we try our best to embed AI into healthcare. But we don't hear from people. Are they ready to? For example, if you go to hospital having surgical whatever issue, and they ask you that, do you agree to have a robot doing surgery on you? Will you agree on that? Will you agree to have a robot doing surgery, whatever surgery? What are you scared of?
Maybe the way we used to think that we usually have a human doctor there who cares for our feeling. If I feel pain, he would understand. And it's the way that we have been grown up. But there could be a robot, but someone has to be behind that robot.
Maybe.
But I'm thinking about my children now who are playing video games all times, and they trust the screen and what is behind the screen, and they know that there's something virtual that manages everything. These people would agree to have a surgery done by robot.
Yeah, actually, just to correct, that's very, very important thing. To correct thing, when we say robotic surgery, it doesn't mean the doctor is not there. It's the one who's with you on the operation theater is a robot, but the doctor is in the side room controlling the robot. He's already scrubbed. He is already scrubbed, so he can intervene immediately. The whole team is still there. Yeah, so maybe awareness and education should be there to educate people.
That's a really interesting use case. It makes me reflect on myself, and this gentleman will have. Sorry, you're next. Makes me think myself. What are the functions that I'm happy to delegate and trust to automation and robotics? And what are the pieces that I'm just not quite there yet? And what's the foundation for that decision making? Is it just generational challenges? Is it just legacy ideas I'm not ready to let go of? Or is there something more fundamental to it? Sorry, for yourself.
Now that you say about the precise machines, I don't remember if the name is correct. It's a Da Vinci machine that they use for medical purpose. That is really precise and go to the point, and it's better than a surgeon, and it's amazing. But there's also the human factor, like the gut feeling that the doctors are like, there is something here that I don't see, but I don't trust, that the machine will go to the point, but the doctor has that feeling, extra thing that the machine doesn't have, and it's really hard to code in the machine.
So have you successfully built a machine with instinct?
No intuition.
Okay,
it doesn't
no
have
intuition.
No.
Okay, well,
machines, they don't have
this
intuition.
gentleman is not going to sign up.
Actually, just to correct it again, when you go into a surgery that performed on you by a robot, who is controlling the robot? It's a physician. The difference is the hands of the physician is not on you, it's the hands of the robot. Previously, the hands of the physician has to be there, and you need a bigger cut in order for the physician or the surgeon to manipulate. But now the physician is controlling the robot through a computer in another room, and he's seeing everything. So he's directing the robot to go and cut and remove whatever. Does that make sense? There is a human behind. It's not automated. No, there is no, till now, there is no fully automated robotic surgery.
Yeah.
It is coming, but we don't know when.
If I may do a tiny disservice to the medical profession, with your permission, I have a friend who's a general practitioner, GP, doctor, okay? She had a patient come in. She couldn't quite work out what the symptoms were. She asked the patients to leave the room to do a completely pointless urine sample so that she could leave the room so she could quickly Google what the symptoms are and what the likely response should be. So let's not hold them up on too high a pinnacle here. There's quite a few decisions maybe I'd be comfortable with technology. We have time for just one more very quick question from you, sir.
I'm going to answer her question.
Please.
But I've always had this idea where AI products, agents, robots should have a fact label.
Fact?
Yes, like the fact label we on the products we buy. So the fact label should tell me the amount of hours this thing was trained on.
Yeah, actually, this is already there.
The precision details.
There is something called AI Agent Passport. It is initiated by the United Nations. And the passport has to, whatever machine that you will be using, the passport will be shown to you. This many surgeon it has done. This successful surgery has been done. And this is the training data. This is how old it is, which company produced it, and all of this stuff.
Brilliant. Now to answer your question, I believe during the patient preparation before the surgery, if you show him or show her the passport, and then the videos from the success story of this machine, I guess that would help, and I would accept.
What if
a
you are
surgeon.
the first patient?
I'd do it.
Well, I mean, I would put another interesting question to you in response. When was the last time you wanted to see the success and fail rate in entire medical professional history of your doctor? You trust a bit of paper on the wall that's framed. You trust a certificate. You set a higher expectation and demand for transparency on the origins of a fact label for an AI machine than maybe you would apply to your own medical practitioner. Really interesting presentation.
you.
I knew it would be. Thank you so much, ladies and gentlemen. Another round of applause.
Thank you.